This is a video review of nomenclature. I am going to start with acid nomenclature. There are two types of acids. The first one is binary acid. To have a binary acid, I always have to add hydrogen and a nonmetal. We will get this covalent compound formula. To name that formula, I will use the word hydrogen, the root of the nonmetal, and the IDE ending. Hydrogen with a nonmetal added to water will form the same covalent compound formula, but in this case we will add the symbols AQ for aqueous, which means dissolved in water. This covalent compound dissolved in water is now an acid, and to name that acid, I will use the word hydro for the hydrogen, the root of that nonmetal, and then add ic acid at the end. Let's try some examples. Here I have hydrogen and chlorine. When I add them together, I need their oxidation numbers. I am going to use the crisscross method in this case to get the HCl formula. This covalent compound is a very polar, or I should say highly polar, covalent compound. Because the electronegativity difference is very high. This means that it's almost ionic in essence, and because of that, we're going to use the ionic naming system and call this compound hydrogen chloride. If I add this hydrogen chloride to water, I am going to form the same formula, but in its diluted form to make that acid. And to name it, all I'm going to do is put this root into that place where the X, that nonmetal, would go. And the final name would be hydrochloric acid. Let's try some more examples. I have hydrogen added to sulfur. I use the oxidation numbers crisscross, and I will get the formula H2S. If I add that into water, I get the aqueous formula. And to name this aqueous formula, I just have to remember what the element is, place it where the X is. In this case, it's sulfur. So I'm going to have hydrosulfuric acid. Next example, hydrogen and phosphorus. Crisscross, the formula will be H3P. This covalent compound added to water or in its diluted form will be my acid. To name this acid, I remember phosphorus, so I'm going to use that root, that phosphor root. Hydrophosphoric acid will be its final name. Okay, so that was the first type of acid. This is the second, oxyacid. To make an oxyacid, I need to again add hydrogen, but in this case I need an oxyanion. Oxyanions are anions that have combined with oxygen, so we use this as our formula HXO. To name that, we have to keep in mind the name of the oxyanion. So if I look at the back of the periodic table and I find the oxyanion ends in ATE, I am going to change the ATE ending to ic acid. If the oxyanion ends in ITE, I am going to change the ending to OUS acid. Okay, just remember that the ic is always higher than the O's. We had examples of this, ferric and ferrous for the ions. Okay, let's try some examples. Here I have hydrogen and I have the anion. In this case, this is the perchlorate anion. or actually I should say oxyanion. The covalent compound formula is HClO4. Notice that we have a +1 and a -1 charge. When crisscross is a 1-to-1 ratio. So that's my final formula. When in its aqueous form, I am going to have my acid. And again, remember I used the root of my oxyanion. And all I do is I change the ATE to ic acid. So this acid is called perchloric acid. Let's try some more examples. We have here the chlorate oxyanion added to hydrogen makes this HClO3 formula. The name of this compound right now, as it is called hydrogen chlorate. If I have it in its aqueous form as an acid, I again have an ATE, so it's still going to end in ic acid. So I have chloric acid. Next example, I have the chlorite anion added to make this HClO2 formula. I call that hydrogen chlorite. In this case, I have ite now, so I'm going to change the ending to ose acid. So the final name is chlorose acid. Okay. Here we have the hypochlorite anion. When I add HClO is the final formula when I crisscross. So the name is hydrogen hypochlorite. If I add it to water in its aqueous form, my acid will be called hypochlorous acid. Here is just a quick view of the notes that we took in class. Okay. Let's try some practice problems on this acid nomenclature. I have done the first two. Okay, here I have hydrogen and sulfur. We already did this one, hydrosulfuric acid. Here we have the C2H3O2. If you look at the back of the periodic table, that is actually the acetate ion. The acetate oxyanion ends in ATE, so I know that it's going to be called acetic acid because the acetate ion ends in ATE. Alright, let's try here some of these over here. Notice on this side, on this left side, we have two elements on each of these. So I am going to use the binary naming. If you recall, binary naming is actually going to be using the word hydro at the beginning. So I'm going to put that first, hydro. Then I have to remember Br is bromine, so I'm just going to use the BROM. And then I know that the ending has to be IDE for that one, for the original ion, but I have to end in ic acid for my acid naming, since this is an aqueous form. If it was just hydrogen and bromine, it would just be called hydrogen bromide. But because it's hydrogen and bromine combined in its aqueous form, it's hydrobromic acid. Okay, let's try the next one. The next one is H and F. If I look at the back of the periodic table, I know that F is fluorine. So I'm going to use hydro again because it's binary. Fluoric acid. Okay, here I have this anion. So look in the back of the periodic table, CrO4. What is that in the back of the periodic table? You have to make sure you look for that specific formula. Okay, so it's actually the chromate oxyanion. Okay, so I'm going to have to call this, since again it ends in 8, I have to make sure that I use the ic acid ending. So chromic acid. That's it. I'm going to go to the very last one. Here, SO4. I think once you use them enough times, you know what their name is without looking. Sulfate. Um, if you know that it's sulfate ion, I know that this is also going to end in ic acid. So sulfuric acid. Notice this is called sulfuric acid when it has the oxygen. It's hydrosulfuric acid without the oxygen. Okay. All right. So now we have changed formulas to names. So now let's change the name to the formula. To do that, you have to make sure that you are paying attention to the ending of this. Okay. So let me think about this. If it ends in ic acid, what should my original oxyanion end in? Okay, so let's go back. It was, when it says ic acid at the end, I have to have ATE at the on the original oxyanion. So that's what I'm going to do. I'm going to put ATE. If this is the phosphate ion, what I have to do is find the phosphate ion. And if you look at the back of the periodic table under the polyatomic anions, you will see that the formula for phosphate is actually going to be hydrogen. We're going to add hydrogen always, right? And hydrogen is always a +1 charge. And I'm going to add that to the phosphate ion, which is PO4. But this PO4 ion has a charge of -3. So when I think, I have to add phosphate plus hydrogen, I have to remember that it has a -3 and I have to crisscross that charge. So the final formula will be H3PO4. Okay. Next one says hydroiodic acid. I know it's an ic acid like this one, but because it has a hydro, I know it's going to be a binary compound. So I know this is hydrogen again, plus iodine. And if I look at the back of the periodic table, well, or the front, I know that iodine has a negative charge. So crisscross, I will just have the formula be HI. One thing that I have to keep in mind is not to forget to indicate when it's an acid. So I have to make sure I go back and I check that my formula, I have to make sure that my formula has this this aqueous, since we're making acids. So AQ. Okay, now it's an acid. Now I can go back and check O's acid, huh? What was the one that had the N O's acid? I have to remember. The 8 would be ic acid, so the O's has to be the ite. So this would be ITE. So I have to look at the back of the periodic table and find the sulfite. Okay, since I have enough space down here, I'm gonna just do hydrogen plus, and this is going to be added to the SO3, not the SO4. It still has a -2 charge. So if I crisscross the formula, it will look similar to this, except that 4 will be a 3. So I am going to have H2SO3. And again, I have to make sure I add the aqueous symbol on the bottom. And now I have a sulfurous acid formula. Nitrous acid. What is that? Nitrous acid. Carbonic acid, nitric acid. Okay, using the same system that I just did, you can figure out the formulas. Okay, so the final formula should be HNO2, H2CO3, HNO3 for nitric acid. Make sure they all have the aqueous sign. Okay. Now let's try naming different types of compounds here. So here we have, to make sure we keep into consideration that you have a mixture of ionic, covalent, acids. So keep in mind you have to look at the first element, barium. So is barium a metal or a nonmetal? If you look at the periodic table, barium is in group 2. And because it's when it's in either group 1 or group 2, I do not use a Roman numeral. This is just going to be called barium. Barium chloride. Okay. HNO3, it has an aqueous. This is a polyatomic ion. I know that I have to name this with the acid name. NO3, if I look at the back of the periodic table, is nitrate. So I know this is going to be nitric acid. Silver, Ag, I know it's silver, I know it's a metal, so I have to use the ionic naming system. So I know it's silver. The question is it going to require or not for me to put a Roman numeral? In this case, if you look at the back of the periodic table, Ag has only one oxidation number, so it does not require. But if you use it, it's not wrong. The next is CuSO3. So I have to keep in mind that when I use the naming system, since Cu copper is a metal, I have to use the metal, the ionic naming system. I do have to also keep in mind that copper has 2 oxidation states. Copper can be +1 or +2. In order to figure out what the charge is, I have to keep in mind that before I start naming, I look at the anion, or in this case the oxyanion. SO3 in the back of the periodic tables, you should figure out that it has a -2 charge. And because this side is a -2 charge, I know that copper is going to be a +2, so that my compound can have a neutral charge. Then I'm going to name this using the Roman numeral. So this will be called copper 2 sulfate. Sorry, sulfite. Remember the SO3 is the sulfite, the SO4 will be the sulfate. Okay, so keep that in mind. Next one is K. If I look at the periodic table, K is in the first group, no Roman numeral, so I can name this quickly. I can say I know K is potassium and the SO4 sulfate. So that's it. That's the name for this compound. Iron, it's another metal. I know I have to look for it, and if I look for it on the periodic table, I see that iron has two possible charges of +2 or +3. So now I have to figure out what P is. So if I look at the back of the periodic table, P is a -3 charge. Since P is a -3, I know that iron has to be, in this case, can only be +3. So I'm going to use a naming system with the Roman numeral. This will be iron 3 phosphide. Phosphide. And I do have sometimes students write the phosphite like this. It doesn't have oxygen, so make sure you write IDE at the end when it's binary. Okay, that's a common mistake. And this one, the next one is NiNSO4. I know the SO4 has a charge of 2 because the SO3 has a charge of 2. In this case, I need to make sure that I write it because the nickel has two possible oxidation states. It can be a +2 or +3 oxidation. So in this case, the SO4 is a -2. So I know the nickel has to be a +2. Because of this, I am going to use a Roman numeral. So this is nickel 2 sulfate. Next one is KMNO4. I know potassium can only be one oxidation state, so I put potassium. MnO4, if I look at the back of the periodic table, I know that this is called permanganate. Okay. Now, nickel again, we mentioned before in the previous one that could be different charges. I have to figure out what Br is. So Br is a -1, and there happens to be 2 in this case, 2 Brs. So I'm going to multiply that times 2 to get a total charge on the anion side of -2. Because of that, my nickel has to be a +2. To name this, I am going to use nickel 2 bromide. The next one, we've been doing a lot of metals here. We've been doing nitric acid, but the majority that we've done so far are ionic compounds. So now here we have SO2. I know that S is a nonmetal, so I know this is going to be a covalent compound. So I need the covalent system. I have to remember that covalent system requires me to use the Greek prefixes. So sulfur, the first element, stays as it is. The oxygen has a 2 on it. I know that 2 in Greek is di, so it's dioxide. So again, for the covalent compounds, I have to use prefixes, so make sure you review the prefixes and use them correctly. Again, on the first element, you never use the mono a prefix on that first element. Okay. PBS2, lead. I know lead is a metal, so I'm going to use the ionic compound system, but because lead can have different oxidation states, I'm going to figure out what S is. S, if I look at the back of the periodic table, has a -2 charge, and I have to multiply that times 2 since there's 2 sulfurs there to get a total charge or oxidation charge of -4 on the anion side. So I know that my lead has to be a +4. Okay, so to name this using the Roman numerals, I have to write lead 4 sulfide. Notice I didn't write sulfite or sulfate is "ide" because there's only 2. It's binary. Next one is P and F. P is phosphorus. Phosphorus is a nonmetal, so you have to use nonmetal covalent compound naming system. So those Greek prefixes, again, the first element never gets mono at the beginning. So this is phosphorus. Number 5 on the F is penta, like the pentagon with 5 sides. So pentagon. Keep that in mind to remember. Number 5. And this is pentafluoride. Okay. The next one looks like, oh, what is this? I don't know if I can name this. But if you look at the periodic table, well, literally the back of the periodic table, I'm going to find C2H3O2, and I know that that is the acetate ion. And the acetate ion, if I look at the back again, I know that that has a -1 charge. Okay, so this has a -1 charge on the anion. There's 3 of them. So in total, I have a -3 charge. Because that side is -3, I know that the chromium has to be the +3 chromium charge or oxidation number. Okay, I am going to name this compound formula as chromium 3 acetate. Next one I have Al2CO3, and I need 3 of those. Okay, so I know aluminum is a metal. I have to say, okay, if this is a metal, aluminum, and if I look at the periodic table, aluminum only has 1 possible charge on it, the +3, 1 possible oxidation number. I don't have to do any of this figuring out what the charge is because I don't need a Roman numeral for that element. So I'm going to simply write aluminum and CO3. If I look at the back of the periodic table, I know that this is carbonate. So the final name is aluminum carbonate. Zinc is the next one. I have zinc, and zinc can have only a +2 charge. So I'm not going to do any calculations for this one. I'm going to simply call this zinc, and the OH is hydroxide. Okay, last one of these, SN. If I look at the back of the periodic table, SN is tin, and tin has 2 possible oxidation states, so I have to do the calculations again. If I do the calculations correctly, by first looking at the non-metal, the oxyanion, or the polyatomic anion. In this case, CN doesn't have an oxygen, so I could just call it a polyatomic anion. If I look at it, it has a negative charge, so -1. There is 2 of them. There's 2 cyanides. And so in total, I have a -2 charge on the anion side. Therefore, I know that this tin right here has to be the +2. Sorry about that. This is going to be, again, the +2 oxidation state tin. And so I name this tin 2 cyanide. And that's it. We have completed this. So the only thing left for us to review quickly is metallic nomenclature review. So metallic bonds, you are going to have in metallic bonds a metal and another metal. Though if there's only one type of metal bonded to itself, then I'm just going to use the name of the metal that I'm using. If there's 2 types, then I'm going to name the metal that has the higher percent composition of the 2, and I'm going to use the word alloy. For example, for that first one type, if I have sodium combined with sodium, and it's not just 2 sodium atoms, it's really a whole bunch of sodium atoms bonded together, and they form this nice structure where you have the flow of electrons, right? The sea of electrons flowing through each of the atoms. So technically, they're giving each other those electrons. That sodium has 1 valence electron, and it's trying to give it, and it gives it to the next, and to the next, and to the next. So these flowing electrons allow the sodium atoms to be able to stick together because of that. Now, if I have iron bonded to itself, then I'm going to just call that iron. I have iron. I have a whole bunch of iron atoms bonded together, and I'm going to name that iron. I have metallic bonds in iron. I have metallic bonds in sodium. Same thing. Now, for 2 types of atoms, when there's 2 types of atoms combined in different proportions, now the amount of each metal is going to vary depending on what properties you want to have come out of that. So if I combine copper and tin, for example, I have copper and tin combined together, the formula is not going to be copper, just CuSN. It's really going to be, that's going to be like the most basic part of it. It's going to form copper tin alloys, or you can call it bronze alloy. This is a very well-known metallic bond, so you should be able to remember that, the Bronze Era. So that was copper and tin combined. If you combine copper and zinc, you have copper zinc alloy, and you create brass alloy. Okay, so that's why we use in bolts for different properties. Again, I said you will have different combinations. You can have copper 31 SN8. You can have different combinations. It's not going to be this basic or a particular standard form. You're going to have different combinations, and it's basically based on what properties you want it to have. For example, bronze bells are made with a specific percentage copper to tin. Most people call that just a copper alloy or a bronze bell. In this case, you can use either. Just keep in mind that you're creating metallic bonds, and then these are the only 2 types of naming. You either name it by the metal name, or you can call the name of the metal that has a higher percentage on it and use the word alloy. Okay, and then these are two different copper alloys making bronze or brass. And that is the end of the nomenclature review.